Okay, in today's lesson, we're going to look at the integral of x, ln of x quantity squared with respect to dx. So first thing here with this question, I'm going to do a substitution to clean this up a bit. I'm going to let that equal the ln of x. And if t equals the ln of x, then I know that dt is going to be 1 over x dx. And from here, I know that e to the t is equal to x. So therefore I can substitute this in here, and we've got here e to the negative t times dx will equal dt. And therefore putting that together, I know therefore that et times dt must equal dx. So I have this relationship right here. I can get rid of the dx and change it to e to the t dt. And I can clean up the x's and change them to et's. So this integration now becomes the integral of, it's not an x anymore, it's e to the t. And I can replace the ln of x with a t. That becomes t squared. And I can replace the dx, as we saw right here, with e to the t dt. So this becomes the integral of e to the 2t t squared dt. So continuing this on here, now this becomes a perfect example of a question that you'd want to use integration by parts on. So I'm going to go ahead and do integration by parts here. Remember that the integral of u dv using integration by parts is uv minus the integral of v du. So I'm going to go ahead and I'm going to let u equal t squared, and I'll let dv equal e to the 2t dt, in which case here du is 2t dt, and v is going to be 1/2 e to the 2t. So therefore, applying integration by parts, I know the integral of u dv, which is this right here, is exactly equal to u times v minus the integral of v times du. And now we have this simplified to become 1/2 t squared e to the 2t minus the integral. The half and 2 will cancel. I'll end up getting t e to the 2t dt. And once again, we can do integration by parts again. I'll let u equal t this time, and I'll have dv equal e to the 2t dt, in which case du is exactly equal to dt, and v is equal to 1/2 e to the 2t. So again, I can go ahead and substitute that in. So we have what we have before, minus the integral. This will become the integral of u times v, so it'll be t times 1/2 e to the 2t minus the integral of v times du, which is just equal to dt. So now we have 1/2 t squared e to the 2t minus 1/2 t e to the 2t minus the 1/2 can pop out, and we're really just taking the integral of e to the 2t dt, and we can finish that off here taking that integral and adding a constant term. The integral of e to the 2t will just be e to the 2t itself over 2, and then I can add a factor of k. So finishing this off here, we get 1/2 t squared e to the 2t minus 1/2 t e to the 2t minus 1/4 e to the 2t plus k. And if you recall here, I had let t equal the ln of x. So this becomes 1/2 the ln of x squared. Right here, we end up getting, if I go to substitute this in, you're going to get e to the 2 to the ln of x, which is e to the ln of x squared. And you know e ln e, in this case here, this is e log base e of x squared, can be rewritten like that. And you know that's exactly equal to x squared here. So e to the power of 2 ln x is equal to x squared. So I'm going to replace that with an x squared. And you can put that in there, and again, that's another x squared. Put your quarter down, and that's another x squared plus k. And just finally cleaning this up here, our final answer is 1/2 ln of x quantity squared times x squared minus 1/2 just ln of x times x squared minus 1/4 x squared plus k. And we have our final answer. I'm just realizing I rewrote the same answer down twice. I thought it would simplify. It does not. So this becomes our integral here. Again, using a quick substitution just to clean it up. You could have gone directly to integration by parts here, but I went ahead and did a substitution first just to kind of make it look a little simpler. But if you want to, you can try to do this directly using integration by parts twice, as I had to do, and you got your final answer. Thank you.